Welcome to episode number 2 of Learn Blockchain with Nkool Marwadi. So, in this episode, we will look into the evolution of blockchain technology. So, we will look into exactly how blockchain technology evolved over the period of time and how it is on the verge of becoming the next big. So, let's get started. Let's have a look what we will cover. So, blockchain, the fifth evolution of computing. Then we will look into brief history of blockchain, in which we will see that the concept of blockchain started evolving from the year 1982. Previous works on a cryptographically secured chain of blocks, and also the first decentralized blockchain, that is Bitcoin. So, how exactly the first decentralized blockchain came into sense. Then we will look into most popular blockchains. You can see the Bitcoin network, the Ethereum network, and the Factom network. Then we will look how blockchain is evolving. So this is very important, exactly how the blockchain is evolving in the current scenario. So we will have a look into the growth of the Bitcoin blockchain file size. So basically, Bitcoin blockchain file is a ledger of Bitcoin blockchain, and how it is growing in terms of its size. We'll have a look, and you will be surprised by the growth of the Bitcoin network. Then we will look into the current blockchain usage, where exactly the blockchains are being used currently. And also, thousands of blockchains and blockchain applications are in existence today. Then we will conclude this episode with the possibilities of a blockchain infused future, where we will discuss what exactly the blockchain holds for our future. So it will be very interesting. So let's get started. So blockchain, the fifth evolution of computing. Blockchain is hailed the fifth evolution of computing. Basically, blockchain is a revolution. As we can see in 1990s, the internet brought about a revolution in computing, and with internet we had this World Wide Web. But the most critical issue of the internet or the World Wide Web is the centralized architecture. The entire World Wide Web (WWW) is based on centralized architecture, client server system. So all the transactions, all the communication occurs via a intermediary, that is a central server. It's a big issue because there comes the concern of security. You use many applications. Use Gmail, for example. Let us suppose in Gmail you are sharing confidential information, but all that information is residing on a central server, and the Google company is the owner of that server. Or you use any e-commerce, any application you use, all your data is residing in a central storage. Its ownership is been held by that company. Definitely, there is an issue of trust. Blockchain solves that problem. That's why it is the fifth evolution of computing. Blockchain is a decentralized system, very big thing. The decentralized system, no central authority, with no central authority managing the data flow. It means le- all the communication you can do directly. As you can see in the figure, the decentralized architecture, node 1 can communicate directly with any of the nodes without requiring a intermediary server or any system. But centralized architecture, as you can see in the left side of the figure, in order to establish any communication, there is always a central authority which is managing the system, which is managing the data flow. Blockchain adds the missing trust layer to the internet. As we have already seen, the World Wide Web, the internet which we are using in today's world, it is having a very deep concern of trust. Why trust? Because it is based on centralized architecture. There is an intermediary involved, and blockchain solves this problem, and blockchain adds the missing trust layer to the internet. And how it does that? Elimination of central authority, as we have already seen, it eliminates the central authority. Large number of full nodes all across the globe. So one more very interesting thing about blockchain is that all your information is not stored in just a single system. There are full nodes. Full nodes are computers. systems that are running some secure algorithms. So these computers are spread all across the globe, and these full nodes are containing the complete record, your complete data, the transaction details, transaction data, all the data. It's been spread among multiple full nodes all across the globe, and it is fault tolerant. Now, why it's fault tolerant in centralized system? Let us suppose that centralized system gets crashed, then the system will go down. You might have seen many of the websites, they go down. Why they go down? Because the central server, if it goes down, then you can't do anything. But in blockchain, it's a network of full nodes. So if any full node goes down also, then also there will be no issue. Why? Because other nodes will take care of the operations of the network. That's why it is fault tolerant. Agreement among group of independent parties. Every transaction, first it's been validated by all the participating full nodes. Once all the full nodes validate, then only the transaction will get registered, and once the transaction is registered, it is irreversible. That's why it is irreversible transaction, very powerful feature. Let us suppose one of the main concern of centralized architecture is uh, the authenticity of transactions, because the owner of the central server can manipulate with the data. How can we rely? The reliability of data is a very big concern in centralized system, the system which we are using today's world. Anyone can manipulate the data because there is an ownership. But in blockchain, since it's an independent network of independent full nodes, independent means anonymous people are managing those full nodes. Anyone can manage. I can also participate. I can also build my own full node. So in order to change any transaction, I have to take agreement. There should be an agreement among all the participating full node. Then only you can manipulate any transaction or change any transaction. So that's why technically it is irreversible. Once the transaction is been done, the data is registered, no one can change that data, and it's a very big thing. So that's why it's at trust, it's at reliability of data. It solves the problem of reliability of data. And permanent records and history. Have already seen, since no one can manipulate with the data will be permanent and it will maintain a history of record, global historic chain of events, and keep track. That's why blockchain adds the missing trust layer, and hence it's the fifth evolution of computing. And blockchain is an all encompassing technology. It means blockchain can conquer the digital space. Now we can see that the application, all the digital stuff you are using, all the digital technologies you are using, most of them are based on centralized architecture. Centralized architecture has conquered the digital space, and blockchain has all the capabilities to replace that centralized architecture. It can conquer the digital space. So it's an encompassing technology that can replace centralized systems by integrating across platforms and hardwares all around the world. So it can be integrated across all the platforms, means all the centralized architecture that can be converted into decentralized architecture using blockchain technology. That's what it's called all encompassing technology. Okay, now let's look into the brief history of blockchain. So exactly how the blockchain got evolved, from where it got started, the history of blockchain. So previous works on a cryptographically secured chain of blocks. So what is a blockchain? Blockchain is cryptographically secured chain of blocks. Let's look into the previous work. Cryptographer David Chaum first proposed the blockchain-like protocol in his 1982 dissertation. So 1982. So he first proposed the concept of blockchain-like protocol. So the name was computer systems established, maintained, and trusted by mutually suspicious groups. In 1991, Scott Haber and Scott Stornetta wanted to implement a system wherein document timestamps could not be tampered. So very important. So document timestamps, definitely they wanted to keep it preserved. The same, the issue of reliability of data. So they worked on the concept of reliability of data, avoid their timestamps from getting tampered. So in 1992, Haber, Stornetta, and Dave Bayer incorporated Merkle trees into the design. So whatever they were implementing, so in that design they implemented the Merkle tree. So basically, the Merkle tree is a very important concept in blockchain. So all the blocks in blockchain, we have all the blocks, they hold the data. So they hold the transactional data in the form of a tree, and that tree we call it as Merkle tree. So as you can see in the figure, we have a Merkle tree where we have the Merkle root, and we have some nodes which are hash, and the bottom layer which is the leaf. So leaf nodes contain the exact data. So the advantage of Merkle design was that Merkle tree was that it improved the efficiency by allowing several document certificates to be collected into one block. So as you can see in the tree structure, all the leaf nodes, so every leaf node is containing a timestamp of a document. So in a single block, you can save the data of multiple documents. So this advantage they got by using the Merkle design. So hashing makes the system secure. It cannot be tampered. Under their company surety, their document certificate hashes have been published in the New York Times every week since 1995. Hash, there is a hash function like SHA-256. So what that function does, takes input and it creates a hash string, you can say that. So whatever timestamp we are passing, and it is converting it to a hash. So all the hash generated by their design, so they published that in New York Times since 1990. So we can see that blockchain is not a new thing. In 1982, the idea of reliability of data started emerging. In 1991, 19, some designs were implemented. A major breakthrough for the blockchain technology was the first decentralized blockchain. So the first decentralized blockchain was conceptualized by a person known as Satoshi Nakamoto in 2008. In 2008, the first decentralized blockchain, the concept was emerged. So that concept demonstrated that a group of individuals who had never met, this anonymous group of individuals, could operate online within a system. So there is a system of anonymous people on a online network that was decentralized to cheat others that were cooperating on the network. So basically, the first decentralized network means a network of anonymous people where no one can cheat one another. Reliability of data comes into picture because there is an agreement protocol followed in blockchain. Any decision you have to take, you should have an agreement of majority of users, then only that decision will be considered. So it was the initial idea proposed in 2008, and in 2009 Nakamoto improved this design further. So he did two things to further improvise that idea. So using a hash cache like method to timestamp blocks without requiring them to be signed by a trusted party. So now let's try to understand what it means. A hash cache like method to timestamp blocks without requiring them to be signed by a trusted party. So see, whenever we talk about a signature, so definitely there is a third party involved. Let us suppose you have any document. Now the authenticity of that document will be by any proof. Signature will be a proof, because let us suppose you have any document, it is signed, then you can say that okay, it is an original document, it's not a duplicate, and it is authentic because it is having a signature. Now with signature there is always a dependency on third party, because someone will sign, and that the person signing the document can be corrupt. How can we rely on that third party? The whole idea of blockchain is to eliminate the third party. Nakamoto solved this problem using cryptography. So what he did, he came up with the concept of digital signature. The beauty of digital signature is that we can make it decentralized. We can eliminate the third party from. So how he did it? He used the concept of hashing. As we have already seen, we have a hash function. Hash function, as you can see in the diagram, it can take any input and it creates a hash output. So as you can see, the fox hash function, it converts into some string set of characters. So that we call it hash. The hash function can be anything, star 256. So what he did, he created the hash of timestamps. So in order to timestamp blocks, the timestamp he used to hash it, and that hash timestamp will be a digital signature. And one more very important feature of hash function is that it is one-way function. With the hash, you cannot extract the original input. And the second important thing is introducing a difficulty parameter to stabilize the rate at which blocks are added to the chain. So he made adding blocks to the chain a bit difficult by introducing a difficulty parameter. So with this difficulty parameter, it was not that much that easy to just flood the blockchain with blocks. So it enhanced the concept further. And in 2009, the improvised design was implemented as a core component of the cryptocurrency Bitcoin. So in 2009, Bitcoin blockchain was created, and that improvised design was implemented. And the Bitcoin blockchain gave birth to Bitcoin cryptocurrency, very popular cryptocurrency. So basically, Bitcoin blockchain, if I talk about, it serves as the public distributed ledger. So what is a ledger? Ledger is basically holding records of transactions. So ledger means all the transaction details it is holding. And distributed ledger means we are sharing the multiple copies among a group of nodes. So that if anybody tampers a single copy, we have other n number of copies to maintain the reliability of data. So, distributed ledger, and public means anyone can access it. Anyone can have a look into the transaction details. It is highly transparent. So, the Bitcoin blockchain network gave a rise to a next big thing, that is public distributed ledger technology. Means we have ledger which is distributed all across the globe, and anyone can peek into it and get transactional details. So high transparency with complete reliability, adding that missing trust layer in the internet. Initially, the words block and chain were used separately in Satoshi Nakamoto's original paper, but they were eventually popularized as a single word, blockchain, by 2016. Okay, now let's look into most popular blockchains in use. So first, let's look into the Bitcoin network. Blockchain originated with the creation of Bitcoin. So because previously blockchain was just a concept, but it came into picture, it came into existence as a technology with the creation of Bitcoin. So Bitcoin is the first digital currency to solve the double spending problem. Now let's try to understand it. So as you can see in the figure, you can get an idea of the double spending problem. The buyer is paying two times double spending. So this problem is solved. So the implementation of blockchain within Bitcoin made it the first digital currency to solve the double spending problem, and that too without the need of a trusted authority or central server. So in today's scenario, we get rid of the double spending problem via a central authority. So in our cases, the central authority can be a bank. So a bank, which is the central authority, it keeps a record of all the transactions. So let us suppose you paid some amount of money to your friend. Now you will have a proof. The bank holds that proof, the transaction. Now anything can happen to that bank. So that proof can get manipulated. The problem of reliability exists. And blockchain, especially this Bitcoin blockchain, solve this problem without needing any central authority. Means now in order to prove any transaction, you don't need any central authority. You have a blockchain, because what is a blockchain? Blockchain is holding all the transactions, and all the record, the ledger is distributed all across the globe. So if somebody tries to manipulate, you have original copies spread all across the globe. It cannot happen that all the copies will get manipulated. It is nearly impossible. So this is how Bitcoin solves the double spending problem. So basically, the Bitcoin blockchain, so it was mainly used to trade Bitcoin and exchange value. So as we have already seen that as soon as it got launched, people started buying Bitcoin, trading on Bitcoin, and you might also have invested in Bitcoins. So the main purpose was to exchange value. So if I talk about Bitcoin network, it has around 5,000 full nodes and it is distributed globally. Because of its size and time-tested security, it's also been used to secure other smaller blockchains and blockchain applications. Bitcoin design has inspired other applications and blockchains. Bitcoin has inspired other blockchains like Ethereum, Factom to come into picture. Okay, now let's look into the Ethereum network. Ethereum is very popular. So Ethereum is the second evolution of blockchain concept. So now how it is the second evolution? So basically Ethereum, what it did to the traditional Bitcoin blockchain, it added a new layer, layer of programming language. So that we call it a smart contract. The beauty of Ethereum blockchain is that anyone can deploy their scripts in the form of smart contracts. Anyone can program it. Initially, Bitcoin blockchain didn't have that capability. Ethereum introduced that concept. What it did, the traditional blockchain, the Bitcoin blockchain, it added a new programming layer, and now people can program the blockchain. So it is also 5,000 plus full nodes distributed globally. So 5,000 plus is a very big number. If I talk about Ethereum blockchain, it's secure blockchain applications and smaller blockchains. And if I talk about usage of Ethereum, so it is also used to trade Ether. You might have invested in Ethereum coins, make smart contracts. We have already seen we can program it and create decentralized autonomous organization. We will have a look into decentralized autonomous organization. Okay, now let's look into the Factom network. So Factom is the third evolution of blockchain technology. Now see, the Bitcoin and Ethereum, they were mainly used to trade coins and exchange value. Their main purpose was to for trading. But Factom, that's why it's the third evolution. It is mainly used to secure data and system. It's not used to trade value. It is used to secure data and system. It operates with federated nodes and an unlimited number of auditing nodes. Its network is small. So basically, we have already seen Factom. It's mainly used to secure systems. That's why it's not spread globally. Its network is small and its architecture is also a bit different. And if I talk about the usage of the Factom network, it utilizes a lighter consensus system. Since its network is small and it's just used to secure systems, so the consensus algorithm, the mechanism, the agreement protocols, it is quite lighter. Lighter consensus system means latency will be less, transaction will be lightning fast. So whenever you need fast transactions, low latency, lighter consensus system, then you can opt for Factom network. And also it incorporates voting. So if you want to set up a decentralized voting architecture, you can go for Factom blockchain. And you can store a lot more information because the network is small. Participants will get more opportunity to store their data, so you can store a lot more information as compared to Bitcoin and Ethereum, because Bitcoin and Ethereum are spread globally and it has been used people all across the globe. The purpose of Ethereum and Bitcoin is to trade value. So it mainly contains the transactional details. You cannot store gigabytes of your stories or any confidential information. It is not made for that. For that, you have Factom. So that's why Factom comes with large storage capacity. So you can store your confidential information, decentralized architecture, which can never get tampered. Okay, now let's look into how blockchain is evolving. So in the current scenario, how exactly the blockchain is evolving. So the growth of the Bitcoin blockchain file size. So the Bitcoin block file. So we also call it as the public distributed ledger of the Bitcoin blockchain. So it contains the records of all the transactions that have occurred on the network. The public distributed ledger of Bitcoin blockchain contains all the transactions that has occurred until now, and that ledger is distributed among 5000 plus nodes distributed globally. So if I talk about the size of that ledger, so in August 2014, the size was 20 GB. In January 2015, the size got 30 GB. From January 2016 to January 2017, the size grew from 50 GB to 100 GB. You can imagine the growth of the file size. And the ledger size had exceeded 200 GB by early 2020. If the size is growing, means the transactions, because what the ledger is holding, it is holding the transactional data, information about transactions. And in Bitcoin, the transaction is all about trading of coins. Let us suppose you buy, so a record get registered, you sell any Bitcoin, the record get registered. So 200 GB of transactional data. So you can imagine the volume at which the blockchain is being used. So with this, we can get an idea about how the blockchain is evolving. And if I talk about the current blockchain usage, the current scenario where the blockchain is being used, the blockchain is used to move money faster, moving money faster. So most up and running blockchain applications revolve around moving money or other forms of value quickly and cheaply. So moving money means exchange of money. Let us suppose you have to pay money. If you use cryptocurrency, you can do it rapidly. So we will have a look into it. One of the most popular usage of blockchain is moving money or other form of value faster, quickly, and cheaply. If I talk about moving money faster, trading public company stock. So many people are trading public company stock using cryptocurrencies and paying employees in other countries. Let us suppose you have a remote setup where you have employees all across the globe. Now you have to pay them. If you go for a traditional mechanism, there you have to pay commissions to the intermediaries, and also the process will be slow. So cryptocurrency solves that problem instantly without any intermediary. You can directly send the value in their wallet, and the person can be sitting in any part of the world exchanging one currency for another. So let us suppose you have Bitcoin. For the that Bitcoin you can get Ethereum coins, so we can exchange currency also. And the second most popular usage is incorporating and governing in a distributed network. Now, see, if we talk about governance, it's a very painful thing. We are seeing corruption all around. When it comes to government, so what is government? Government is basically managed by politicians, leaders. They are also people. So there is a chance of corruption. Let us suppose if any politician is corrupt, then definitely he will corrupt the system. So that's why there is a quest for governance in distributed network. It's a big thing. It will eliminate all the intermediaries. So if I talk about incorporating and governing in a distributed network, one of the most popular use cases is decentralized autonomous organization. As the name suggests, decentralized means no intermediary. It is a decentralized organization, no single owner. A group of anonymous users are operating that organization. And autonomous means independent. Nobody can control that organization. No ownership. It's been operated independently by anonymous users. So that is decentralized autonomous organization. Decentralized autonomous organizations, they represent a new way to organize companies, incorporate companies, and invest in funds via the Ethereum network. So it's a revolution in the way the company has been incorporated, the company has been managed, organized, and the way the company has been funded. And also, if I talk about distributed governance, government backed land record systems. So it's also very important to consider. If I talk about land records, the proof of ownership is a piece of paper. Let us suppose you acquire any land, and now I claim that land to be mine. You say no. See, this is the proof of a piece of paper which says that okay, this land belongs to me. And Let us suppose that piece of paper somehow it gets lost anywhere, or it gets spoiled. Then you will say, okay, you visit that government site, and in that there is a registration. Now that government website is also a third party. It is being managed by a central authority. If somebody hacks it, somebody manipulates the data, then what? How can you prove your ownership? So here blockchain plays a very important. So whenever I talk about distributed governance, the reliability of data comes into picture. So all the confidential sensitive information like land records, that can be stored in blockchain. Identity management, international travel security application like passport or any confidential information or sensitive information, you can store it in blockchain and it will be there forever. No one can tamper it. So it's a big thing, a revolution. And the next usage is building secure applications and hardware. So using blockchain, we can build secure applications and we can secure the hardware also. Blockchain has been quite instrumental in securing Internet of Things systems, IoT systems. So the United States Department of Homeland Security has been investigating blockchain software that secures Internet of Things devices. United States, they are heavily investing in securing the IoT network using blockchain technology. See, if I talk about IoT, so IoT devices are vulnerable to spoofing and other forms of hacking. And also IoT devices have also been more pervasive and security has become major concern of IoT devices. So that's why blockchain is playing a role securing IoT devices. Also hospital systems, because hospital contains lots of confidential information. Healthcare data is confidential. You never you will never want to share your uh, sensitive health data, and all the health record in the current scenario is centralized. Somebody is the owner owning that system, and anything can happen to that your health data. And also blockchain is being used in self-driving car, because in self-driving car all the crucial information it want it to be tamper free. And also safety systems. So when if I talk about safety, blockchain provides that safety. Okay, now let's look into thousands of blockchains and blockchain applications are in existence today. So blockchain is a market of thousands of cryptocurrency. You might have seen, you just go to any cryptocurrency exchange like Binance, you will see a list of cryptocurrencies. So every cryptocurrency is a blockchain, like Polygon. So Polygon is a blockchain. Name any cryptocurrency. Dogecoin, it's a blockchain. So market of thousands of cryptocurrencies. And blockchains are moving beyond the trading value market. So initially, as we have seen, Bitcoin, Ethereum, their main goal was to trade value, and the thousands of cryptocurrency we have seen, these blockchain are mainly used to trade value. Means you can invest in coins and you can trade coins basically. But blockchains are moving beyond trading value. So blockchains are being incorporated in all sorts of industries like automobile, government, services, healthcare, insurance, energy, real estate, sports, entertainment, e-commerce, banking, finance, supply chain, retail. If I talk about use cases, so we have already seen cryptocurrencies. Also decentralized finance application. Finance should get decentralized. If I talk about finance, mutual funds, insurance, mutual fund, let us suppose from 10 years you are investing, you have invested lots of your savings in mutual fund. Now what is the proof of ownership? A document which can be tampered, a record which is stored in a central server which can be hacked, anything can happen to that. How you can prove your ownership? You have invested your hard earned money. Now you should have a authentic proof. So blockchain will play a role. So blockchain can bring a new revolution in decentralized finance applications. Non fungible tokens, you might have heard about. NFTs, very popular. And smart contracts. So these are many of the use cases we can see in today's scenario. And also one more very interesting scenario you should consider, that is Walmart blockchain. So Walmart was facing issues due to some bad quality. So the issue was high return rate and large amount of refunds. So people were just returning the products because they were not liking. There was some quality issue, and Walmart was not able to identify exactly where the issue was. It was not able to determine the point of failure. Either the point of failure was in farm or the storage or the transportation, processing, distribution center. They were unable to track exactly where the issue was. Walmart incorporated a blockchain, and each process got inscribed into the Walmart blockchain, keeping track of issues. Since each and every process got inscribed, they just had a look into it, and it helped Walmart to identify the problem areas and fixing them. Company like Walmart solved one of its critical problems using blockchain. Okay, now let's look into the possibilities of a blockchain infused future. So, what future holds for blockchain? What is the future of blockchain? So, blockchain has excited the imaginations of various stakeholders like businesses, people, governments, political groups, and humanitarians all across the world. So, they are started looking blockchain seriously. They are started to explore solutions using blockchain. Investments and initiatives by various countries. Countries such as UK, Singapore, and UAE have active investments and initiatives exploring blockchain. Countries are investing and promoting initiatives of blockchain. So countries see it as a way to cut cost. As we have already seen, exchange of value means transfer of money from one country to another country can become much more affordable. So blockchain can cut costs. So they are seeing it as a way to cut cost, create new financial instruments. NFTs we have seen, it's a new financial instrument. Cryptocurrency in itself is a new financial instrument. Keep clean records, very important. Okay, now let's look into the Essential report. According to Essential, an application of the diffusion of innovation theory suggests that blockchains attained a 13.5% adoption rate within financial services in 2016. In 2016, the adoption rate of blockchain was 13.5%, and therefore it reached the early adopters phase. So in 2016, the blockchain technology reached the early adopters phase because 13.5% companies, means all across the globe, started adopting blockchain technology. So we can see still blockchain is quite a new field. Only 13.5% adoption in 2016. It's a big opportunity, and definitely it will grow. It will be the next big thing. Global Blockchain Forum. So industry trade groups joined to create the Global Blockchain Forum in 2016. Global Blockchain Forum is an initiative of the Chamber of Digital Commerce. So in 2016, a Global Blockchain Forum was formed. People started taking blockchain very seriously in terms of trade, in terms of digital commerce. Gartner report. So in May 2018, Gartner found that only 1% of CIOs, Chief Information Officers, indicated any kind of blockchain adoption within their organization. So in 2018, May 2018, only 1% of CIOs reported that okay, we are using blockchain technology within our organization. Only 1%. And only 8% of CIOs were in short term planning or looking at active experimentation with blockchain, and only 8% of CIOs were willing to invest in blockchain. For the year 2019, just 1 year, Gartner published one more report, and according to that, 5% of CIOs believed blockchain technology was a game changer for their business. So we can see that blockchain is the future because blockchain is solving one of the most critical problem of computing, that is reliability of data. In your laptop, the data is safe because you have the complete ownership of laptop, but you are using internet. All the applications you are using, your data is being stored in some third party servers. Ownership is with some third party. How you can believe that third party, regardless of whatever claim they make, we can't trust on them. So reliability is a very major concern, and blockchain solves this problem. Okay, so we came to end of the episode number 2. So thanks for watching Learn Blockchain with Ankul Marwadi. I hope you liked it. Do like this video, comment your feedback, suggestions, and share this video in your circle so that people will get more deep insights on blockchain technology. Thanks again.